So let's start reviewing for test number 1. First thing we want to do is talk about functions. So here we have an equation. In this equation, we want to determine whether or not y is defined as a function of x. So the best way to do that is to solve for y. And so if you solve for y, you would get x plus 9 equals y squared. And then to get rid of the squared, you take the square root. But whenever you take the square root, you need a plus and minus. So y, So y equals plus and minus the square root of x plus 9. Well, there you go. If you were to plug 1x into this function, into this equation, into this equation, you would get two values of y. You would get a positive and you would get a negative. Let's say x equals 1. You would get the square root of 10. But y would equal plus and minus the square root of 10. So 1x of 9 going to two different y's, not a function. Okay? Here you have a graph. Then if you want to determine whether or not this graph depicts a function, we can do the vertical line test, in which case we put a vertical line anywhere on this. That vertical line only hits the equation one time every one of these. Therefore, it's a function. If we said we had a graph that looked like this, we tried to do the vertical line test on that. Well, the problem would be we would hit multiple points with each vertical line, and therefore that would not be a function. Here we have some questions about domain and range. First, we just have a set of points. Now, in this set of points, okay, the x values, here, 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 those x values are all going to be considered my domain values. So my domain, I can write as a set, and that would be 1, 4, 11, -7, and -2. Those would be all the x values that we just saw in each one of these points. And then the range values would then be the y values here. Oh, that might be a little too dark. So let's go with green. So the y values here, oh, same color again, here, 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 here. So then if I wanted to say, well, what's the range? The range, we could write as a set as well, and that would be -10, -7, -8, -3, and -2. So when you're dealing with a set of points, it's actually really easy to find the domain range. X domain, Y range. All right. Now here is an equation, specifically the equation of a function. We can find a domain range. Well, it's the same idea. Domain's usually easier. What could you plug in for x that would allow you to evaluate this function? So what could you plug in for x that would allow you to cube it and then multiply by 9? Pretty much anything. Like you can cube any value you want, you'll get an answer, then take that answer, multiply by 9, you'll get an answer. So as long as you can plug something into this function and be able to evaluate it, it's in the domain. So the domain here, we could say, is just the set from -infinity to +infinity. Now as far as the range goes, that can be a little bit trickier. There's a couple ways we can do that. We could look at the graph of this equation. We could think about what would happen when we plug an x value in here, etc. Well, a couple of things. If you look at the graph of that equation, the graph of it would look like this. Right? And you would want to know what y values we used in this graph. That would be your range. But another way to say is, all right, if I take any one of these x values and I plug it in here, what's going to happen? Well, if I take a negative x value, I plug it in, I'm going to get a negative value, because you cube a negative, you get a negative. If I plug a positive x value in here, cube it, I'll get a positive. And as the x values grow either towards positive or -infinity, that value would grow. Multiplied by 9, same thing. So ultimately what's going to happen here is the range is going to go from negative infinity to positive infinity as well. And that can be seen even more clearly in this graph. Look at the y values that I would get for every point. The y values would go up to positive infinity and y values would go down to negative infinity. All right, so here what we want to do is just evaluate the function. So they want us to plug -5 into this function. That should be really easy. So f of -5. Well, the function tells you what to do with the x that you plug in. You're going to subtract 7 from it, so -5 minus 7, and then you're going to square it. Well, that would be -12 squared, and -12 squared would be positive 144. So that is f of -5. All right, so here we have a word problem. Let's look at it. A deep sea diving bell is being lowered at a constant rate. After 8 minutes, the bell is at a depth of 150 feet. After 55 minutes, the bell is at a depth of 1,800 feet. What is the average rate of lowering per minute? So, if we want to do that average rate, it's a rate of change. What we want to do is the distance over time. Or more specifically, the change in distance over the change in time. And so, well, the change in the time was 55 minutes to 8 minutes. Now, it doesn't matter how you do it. You could have said 8 minutes to 55. You could have reversed the order here. But whatever you do in terms of the change in time, make sure that the distance corresponding to each one matches up accordingly. So since I put 55 minutes as my first time and 8 minutes as my second time when I'm looking at the change, I'll put the distance that's associated with the 55 minutes, which was the depth of 1,800 feet, and then 500 feet for the 8. Okay? So that as long as those match up, then I'm fine. So these go together, these go together. So then you do that, you're going to get 1,300 over, what's that going to be, 47? So if you want to, you can leave it like that. That'll be the feet per, what are we in, minutes? That would be the rate. We could simplify that. We could turn into a decimal. They all would be acceptable answers. So if we turned into a decimal, 1,300 divided by 47, you would get 27.7. So roughly 27.7 feet per minute would be the average rate that they would be lowering this deep sea diving bell. Ultimately, all we're doing here is calculating slope, average rate of change, slope. They're the basic things. Instead of change in distance over time, we think of slope as change in y over change in x. But anytime you're dividing two changing values is relatively related to slope. Here's the graph of a function. We want to determine the domain and range. Let's just make this picture a little more clear. Here, we're starting at this point here, and this is curving upward, and it's going to continue to curve upward forever. So keeping that in mind, if we look at the domain and we look at the range, domain are the set of x values that we're working with. So if you look at it, the very first x value we would have would be an x value of 0, and then every point on the graph would result on an x value along the axis this way. Well, that'll basically take us from an x value of 0 up to positive infinity. So I could just write, say, the domain is 0 to infinity. I'm going to use a bracket here, not a parenthesis, because this point has that x value. So x of 0 is an actual domain value. Now the range, on the other hand, are the y values. And if you look at the y values that we're working with, we have this y value here, and then every point on this graph as it continues to go up will have a y value somewhere along the y-axis this way. So my y values, my range values, will start at -3, and that's going to be included, so bracket, all the way up to infinity. Here we want to identify the intervals where the function is changing in a certain way. In this case, it's asking us to figure out where is it increasing. So if we want to look at where this is increasing, increasing means it's going up from left to right, so clearly right there. Okay? Now to answer the question, you want to state the x values for which this is happening. Well, the x values for which this is happening, it would be this x value here, all the way up to this x value here. So the x values will be from 0 all the way to 3. So we could say this is increasing on the interval from 0 to 3. Now I don't include 0 or 3 because that's where a change is happening. This point right here, it's going from decreasing to increasing, so I don't include it in either. This one is increasing then constant, so I don't include that one. So simply parentheses around it, but you labeled the x values for which this is happening. We have a relatively similar picture, but in this case we want to look at decreasing. Well, decreasing means we're going down from left to right, so clearly this is where it's going down from left to right, and you want to identify the x values for which that's happening. So here to here, the x values in between, so this thing we would say is decreasing on the interval from -3 to -2. Again, parentheses on each one because I'm not going to include -3, I'm not going to include -2, but I want everything in between. That will represent this place where it's going down in terms of the x values. Here we have some more line questions. In this case, first, the slope of the line. That's a very easy one. We have our formula for slope, which is y2 minus y1 over x2 minus x1. So we'll have 8 minus -6 over -1 minus -9. So just make sure that you're subtracting negatives appropriately. It really doesn't matter which one you call x1 and x2, but once you do that, make sure the y2 and the y1 are associated with those. So in this case, -9 and -6, I called that 0.1. They go together. The 8 and the -1, they're going to go together. Okay, so what do we have here? We're going to have 8 plus 6, because the double negative, 14, and -1 plus 9, so we're going to have 8. If we simplify that, 7 over 4, there's your slope. For the next one is a little bit more, passing through 3, 4, perpendicular to this line. We want to write the equation for that given information. Put the answer in point slope form. So first off, what we need to do is find the slope of this line. Well, that's easy. The slope of that line is 9. And then we want the perpendicular slope. Well, the perpendicular slope would be the negative, so opposite sign. This is positive, so negative reciprocal. Negative would be opposite sign, and reciprocal means 1/9. Flip it over. That would be the slope that we want to work with. So we have that slope, we have this point. Well, what we have is this thing called the point slope formula. Y minus y1 equals m times x minus x1. And so we're going to take this point, plug it in for the x1 and the y1, and we're going to take the slope and plug it in here, and so we get y minus 4 equals -1/9 times x minus 3. That would be the equation of the line. Not the greatest way to write the answer, so typically what we'll do is rewrite it in either standard or slope-intercept form. In that case, we would say a couple of things I can do here. I'd like to get rid of the fraction, so I'll multiply the 9 over this way. So I'll have 9 times y minus 4 equals the -1 still there times x minus 3. Okay, let's get a little bit more space here. So I'll erase this. Then multiply the 9 in, the -1 in, so we have 9y minus 28. Oops, not 28, 36 equals -x plus 3. So now I can move the 36 over, so 9y equals negative x plus 36, so plus 39, and then divide by 9, so y equals negative x plus 39 over 9. And that's one way to write the answer. There are multiple ways, but to me that is probably one of the better ways that I could do it. Another way would be standard form, put x and y on the same side of the equation, so bring the x over here, in which case I would have x plus 9y equals 39. Same equation that I have here, just a different form. Usually slope-intercept form and standard form are the two most acceptable ways to write the final answer. So here we're going to get into systems of equations. So in this system of equations, ultimately what we're going to do is determine whether or not we have a solution to the system. So does this point satisfy the system? Well, is that point a solution to this equation and this equation at the same time? We'll plug it into both and see. So if I take 2x plus y equals negative 14, and I plug that point in, I would have 2 times negative 4 plus negative 6 equals negative 14. Well, that's negative 8 plus negative 6 equals negative 14. Yes, negative 14 equals negative 14. So that one checks out. Now if I plug it into the second equation, 4x plus 2y equals negative 28. Again, x is negative 4 and y is negative 6. Does that satisfy the equation? Well, I would get negative 16 plus negative 12 equals negative 28. Well, yeah, that's negative 28 on one side and negative 28 on the other side, so yes. So determine if the order pair is a solution to the system. Yes, it is. So now we're going to get more into actually solving the system. So we got to find the solution. In this case, we'll just use the addition method to do it. This is already set up pretty nicely for the addition method. If I were to just add these two equations together right now, the y's would cancel each other out. So I would have 2x equals 10, and therefore x equals 5. And there's one of my solutions. I could take that solution and plug it into either one of those equations to find the y, or I could go back and eliminate the y. Both are acceptable. These are pretty easy equations, so I think the best bet would be to just say, all right, let's plug this into, say, the first equation. So x is 5 plus y equals negative 1. So y equals, subtract the 5 to the other side, negative 6. So your solution would be 5, negative 6. That ordered pair, that point, solves the system. So here we have a word problem that's going to create a system of equations. So a manager of a bulk food establishment sells trail mix at $7 per pound and premium cashews at $14 per pound. The manager wishes to make 140 pounds of a trail mix cashew mixture that will sell for $11 per pound. How many pounds of each should she use? So let's establish two variables. X is your amount of trail mix. And y is your amount of cashews. Okay? Well, we know that the amount of trail mix plus the amount of cashews has to be a total of 140 pounds. So we have that equation. And now we need another equation. Well, we need a money equation. Well, if we take the amount of trail mix times how much per pound, so that'd be 7 times that, plus the amount of cashews times the selling price per pound, so 14 times y, should give us the total amount of money that we would have to have in the end. Well, if we know we have 140 pounds in the end, and we know it's going to be $7 per pound, we can figure out the total amount of money that it will be at the end by doing the 140 times 11. And that comes out to 1,540. So the money equation in this case will sum up to a total of 1,540. So there's your second equation. And then that's the system that you're going to want to solve. So what I can do is I can multiply the first equation by negative 7 and this will give me negative 7 times 140, and I can add it to the second equation. That'll cancel the x's, giving me just 7y equals 560, and therefore y would be 80. Now, knowing that y is 80, and we know x plus y has to equal 140, that means x is going to have to be 60. Well, what does that represent? That's how much of the trail mix, and that is how much of the cashews. So that's the total number of poundage for each that needs to be used. Trail mix, 160 pounds, and cashews is going to be 180 pounds. Saw that once our systems get a little bit more complicated, matrices are probably the better way to go about solving them. And so this linear system has 3 variables and 3 equations. Now we don't have to solve this one, it just wants us to write the augmented matrix. So the augmented matrix is basically taking all the variables and the equal signs out of it and just focusing on the numbers. So in this case, the augmented matrix would be 7, negative 2, 5, 3, 7, 9, negative 2, negative 2, 6, and that's basically these numbers in this column, these numbers represent this column, and these numbers represent this column. Then we put a straight line where the equal sign would be, and then we put the numbers on the other side of the equal sign here. And that would be your augmented matrix. Very easy to do. And by just focusing on the number values, we can then use that to help us solve the system using matrices. So now we want to start using this matrix method to solve a system. We'll start with an easier system here, just 2 variables, 2 equations. The Gauss-Jordan method or row reduction method is the way we're going to focus on it. First thing we want to do is create our augmented matrix. So we would have 5, 6, 1, 3, straight line, 12, 9. So the first thing we're going to want to do is we're going to get a 1 in this first position here. So a couple ways we can do that. One way we could do that is to first switch rows around, or we can just straight going after it. It doesn't matter if you find one way is easier than the other, then that's what you'll do. There's multiple ways to attack this problem. So the first thing I'm going to do though is I'm going to take row 1 and I'm going to take row 1 and divide it by 5. And that'll give me my new row 1. And so I like to identify what I did so I can go back and check it. So if I divide by 5, I'll have 1, 1/5, and 12 fifths. And then I still have a 6, a 3, and a 9. Okay, the next thing you're going to want to do is you're going to want to get a 0 in this position here. So in order to get a 0 in that position, I'm going to take row 1 and multiply it by 6. And then I'm going to subtract row 2, and that'll give me my new row 2. And so I'm going to have 1, 1/5, and 12 fifths. And then I'm going to multiply that by 6, okay, and subtract it from row 2. If I multiply this by 6 and subtract it from here, that makes it a 0. Now here's where the computation starts to get a little bit trickier. I'm going to take this and multiply it by 6, which will give me 6/5, and then subtract the 3. We may have to do some scratch work here. So 6/5 minus 3. Well, that would be 6/5 minus 15/5, which is 3. And that would give me negative 9/5. So I have negative 9/5 here. And then I can do it again for the 12 fifths. Multiply that by 6. If I multiply that by 6, I get 72 fifths. And then I have to subtract this value. So subtract 9. 9 would be 45 fifths. Okay? And that'll give me my new position here. All right, again, computation a little bit tricky, but we can do it. So 72 minus 45, we can easily do that. And if you have a calculator, it makes it a little bit easier to do as well. So I'll allow you to use calculators. So we're going to get 27 fifths. So that'll be the new value here. Okay. All right. Last thing we want to do is we want to get this number here to be a 1. Well, if I take row 2 and I multiply it by a negative 5/9, the reciprocal of this number, that will give me my new row 2, and therefore that's going to make this a 1. So what do I have? I'm going to have the 1, the 1/5, 1/5, sorry, that's 1/5, and a 12/5, and then I'm going to have a 0. That's going to become a 1, and then I have to take negative 5/9 and multiply it by here. Well, the 5's will cancel, and then the 27 over the 9 will give me a 3 and a negative, so negative 3. So that's my new matrix. Now, what I need to do is use that matrix to then solve the system. Once I have the lower echelon matrix created, I can then solve the system very easily. So let's rewrite what we had. We had 1, 0, 1/5, 1, 12/5, and negative 3. Okay. So this one here is basically telling me, remember, the first column represented x, the second column represented y. So it's telling me that y equals negative 3. There's one of your solutions. Then what I can do is use that in the original equation, or I can use it in one of the first line, which is basically telling me that x plus 1/5 y equals 12/5. I could use it there, or I can go back to one of the original equations, whatever you decide. If we use this, what we have in front of us, this matrix, I would plug this y in here, in which case x plus, this will be negative 3/5 equals 12/5. I can then move this to the other side, and that'll give me that x equals 12/5 plus 3/5, because it's negative. Let's move to the other side, it'll be plus. So that'll give me 15/5, which will give me 3. So x is 3, y is negative 3, so your solution is 3, negative 3. So very similar to the addition method, but using matrices to do it. Now, typically on a smaller system like this, you probably wouldn't use matrices as much as just straight elimination by addition like we did previously, but when the matrices get bigger, it's definitely more beneficial. All right, so here now we have a 3x3 system, and we want to use Gaussian elimination, row reduction, in order to solve it. So first thing we want to do is create an augmented matrix, and I think the neater you are with this, the more you write down, the better off you'll be. So we have 1, negative 3, negative 5, straight line, 1, negative 3, 7, 9, 1, 1, 0, because there's no y here, 4, negative 5. Right. So that's our original augmented matrix. Let's start working with it. So we want to get a 1 in this first register. We have it. Then we want this and this to be 0. So let's work one at a time. So if we take 3 times row 1 plus row 2, we'll get the new row 2. And I'm going to do two things. I'm also going to do row 1 minus row 3 to get my new row 3. So we'll do both of those things. So then the new augmented matrix with each of those reductions would be what? Well, let's work one at a time. So 3 times this plus this. That would make that a 0. Okay, negative 3, negative 5. We're not changing the first row, so I'll just leave that there. And then we're going to do 3 times this, which should be negative 6, plus this, which will be 1. 3 times this, which will be negative 15, plus this would give me negative 6. 3 times this, plus this, so that'll be 3 plus 1 would give me 4. And so that takes care of that row. Then we're going to take row 1 minus row 3. So this minus this